8.7, we introduced something called the imaginary numbers. For the majority of you, imaginary numbers is not going to have a particular lot of meaning, and that's because you're going to be going in a direction that's not going to encompass it. If you're going into the sciences, you'll run into it in engineering and mathematics and some of the rest of it. You'll be working with imaginary numbers there, but certainly not for the majority of you. That's not going to be the case. And I should have actually blown this up a little bit. An imaginary number, and it's I, is defined as the square root of -1. So up until now we've said the square root of a negative number was not a real number. It is a number, but it is an imaginary number. There's only two things in this class that you need to know, is that I is the square root of -1 and I squared is -1. Those are the only two things. You can go into other intermediate algebra classes and you'll have instructors that basically say, oh, it's just so much fun to do I squared, I cubed, I to the 4th, I to the 5th, I to the 23rd. Who cares? I mean, I'm a math major and I've never had to worry about it, so at which point the only thing we need to be concerned about is I and I squared. All the other ones are, who cares? It's a cute pattern. I mean, that's what it amounts to. And I don't think it's all that cute, but that's okay. A complex number is of the form a plus b times I, where a is called the real part and bi is called the imaginary part. And by the way, your calculators, if you were to take the square root, and it depends upon how mine's set at the moment, and let me check this out. Up clear. Okay, it's set correctly. So if I were to, in my calculator, take the square root of -1, it's going to come out to be a non-real number. It says it's not a real number. That's why my calculator is set up to do just real numbers. Now, what does that mean? Well, for those of you who are going to be writing some computer programs or going to be having to interface with the computer somewhere along the line, is that real numbers, the computer sets aside one box, and that one box contains a number. It is a decimal number, because computers deal with decimals. They don't deal with actual physical square roots. They deal with approximations. The problem with a complex number is that there are two parts to it. So what the complex number, what it sets aside, is two boxes. A, which is the real part of the complex number, and B, which is the imaginary part of the complex number. So as long as my calculator is set to only handle real numbers, it won't do imaginary numbers. Now, what would I have to do? And this would be the same on any computer, by the way. I would have to go in and I would have to set my calculator to be able to do imaginary numbers. Then, if I take the square root of -1, if I've done this correctly, it'll tell me it's I. It will do, but in order to do that, I've had to say, I'm going to put in numbers, and the numbers are going to have imaginary answers or have the possibilities of imaginary answers. So as a result, anytime I put a number in, it sets a box aside. If it's only a real number, it sets this imaginary part to 0. If it's only an imaginary number, it sets the real part to 0. If it is a complex number, in other words, it's got two pieces, it will have two boxes, one for the real part of the number and one for the imaginary part of the number. but you have to set your calculator in order to be able to do that. Now you can check your answers, and what I did is I went to mode on the grapher, and then I just came down, and you can see here's real and here's A plus BI. That set my calculator to do imaginary numbers. I won't do it with X's, of course, but it will do it with numerical values. But I had to tell it that so it would actually be able to handle it, and it sets the two boxes aside to be able to do that. So that's why most calculators can't do imaginary numbers. Why? Because an imaginary number demands two spaces. The calculators only set up one. Computers normally only set up one. So when I was working with imaginary numbers and writing programs, I had to declare the variables or tell the computer the variable I'm working with is a complex number. Then automatically it would set the two boxes aside. Otherwise it would come back with the same error that I would get with the calculator set to just do real numbers. So a lot of calculators, the graphers, can do imaginary numbers. Okay. Now how does this fit into the scheme of things? This is the biggest system that you guys will ever see, and we call it the complex number system. And what it does is it's enveloped the whole system into one big thing. So our number system did not come as, essentially they didn't throw the baby out with the bathwater. What they did was they started with the natural numbers, or what we call the counting numbers. And that's all you needed. If you were a sheep herder out there in the field with sheep, all you were concerned about that when you had as many sheep coming back as you had going out. And you were counting whole sheep, not parts of sheep. A part of sheep means that you failed somewhere along the line. So all you needed were the counting numbers because you were counting stuff. And then once you ended up basically trying to keep track of stuff, you needed negative numbers, or you needed whole numbers, by the way. And that, by the way, counting numbers does not include zero. But if I had zero of something, I needed a zero to represent that. That created the whole number, so enlarged on that. Then, somewhere along the line, you came in and needed negative numbers, so they took the whole numbers, what existed, expanded it, and that included all the negative numbers. And they called that the integers. Once you ended up having a person who was in business, you maybe didn't want to sell a whole bushel of something. Maybe you wanted to sell a half of bushel. You needed a representation for that, or a number representation. That's where the rational numbers came into being. And the rational numbers were the only thing that existed for a very, very long time. And it was a Greek by the name of Pythagoras who came up with the idea, and we've looked at, I think, the Pythagorean theorem when we did the distance formula, who came up with the idea is there was something more than just the set of rational numbers. Now, of course, for a very long time, he was persecuted because he said that. What do you mean there's something different? Well, if you're dealing with the right triangle somewhere along the line, you're going to find out that things are not going to come out fractions and whole numbers. Just not going to. And he found out that there was this thing called an irrational number, something like the square root of 2. And that is something that can't be represented by a terminating decimal or a whole number. Like a terminating decimal would be 1.5. A non-terminating decimal would be like 1/3, which is 0.33333333. Those are the rational numbers. The irrational, they're non-terminating, non-repeating decimals. So that added this group. So the real number system, which is what we've been working with until now, is just this whole group right here. And now we're going to add to it the imaginary numbers. That's this piece here, where we defined I to be the square root of -1. It's by definition. And so we would have 3i, -2i, 7.3i. Those are all imaginary. And then you have these hybrids, which we call complex numbers. 3 plus 2i minus 5 plus 7i, 7.2 plus 0.03i. Any real number can be in the front as either A or B. So the complex number system now becomes this whole thing. It includes the real numbers, It includes the irrational numbers. It includes the imaginary numbers. And you say, well, how do I know it includes the real numbers? Well, if a complex number is a plus b times I, if b equals 0, I'd have a plus 0 times I, which is just a. And a is a real number. So that says real numbers are complex numbers. Imaginary numbers are complex numbers. These hybrids are complex numbers. This is the system in its entirety. We call it the complex number system. There isn't anything bigger than it. That's good news. That's good news. And that's what we're going to be working with in this next section and actually in the next chapter as well. Will be the complex number system.